Hi everyone, and thank you for joining. In this video, we'll go through the step-by-step process to solving a quadratic equation by the method of completing the square. Now, we have mentioned completing the square method in converting the quadratic functions or the equation of quadratic functions of the form y equals ax squared plus bx plus c into the vertex form y equals ax minus h squared plus k. Now, the process of going from the standard to vertex form is called completing the square. But remember that this is the equation of a quadratic function, which means that we have a connection between x and y in these equations. And what we are trying to do today is to solve a quadratic equation or find the zeros of a quadratic equation by using the method of completing the square. And even though the process will be similar for most of the time, there are steps or parts of it that are a little bit different, and mixing up the steps can mix up the solutions really badly sometimes. So I'm going to try to go over those key points as well. Okay, so just keep that in mind though. So whenever we solve or whenever we complete the square in quadratic functions, the process will be similar to this. So what I'm going to do actually is I am going to go through the process of completing the square to solve a function and to solve an equation and to write the equation in standard vertex form. So I'm going to rewrite this function x squared minus 6x minus 27 as a function. So this is the function, and this one here is the equation, because I want us to see the discrepancies in the methods. So I'm going to start with some of the things that we know. So, and we have recently reviewed as well. So to convert this equation to vertex form, we first group the first two terms. And that's how we started completing the square. Now, when we are in quadratic equations, instead of grouping the terms, we separate the terms that have variables and we take the constant term to the other side. So here you group the terms with variables x squared and x together, and we leave the constant out. Here we take the constant to the other side. Now, the next step in completing the square in quadratic functions is to add the number that makes a perfect square here. So what we did was we looked into the number -6 in here, and then we said take -6, divide it by 2, and then square it. And that will give 3 to the -3 power 2, which is 9. So we said that we're going to write what we have, and then we're going to add 9 because 9 is what's needed to make a perfect square, and immediately subtract 9 because we cannot change the value of the expression. So in this case, we've said that we've added just 0, and then minus 27. Now, how is this the same or different in quadratic equations? In quadratic equations, again, we're going to complete the square just like we did in the functions, but we're going to complete the square slightly differently. So we're going to say that x squared minus 6x is going to need a 9 to become a perfect square. And what we do is, instead of adding and subtracting a 9 to one side of the equation, here we're limited because we cannot do this to both sides because y has to be on its own all the time. So what we do in equations is we add the same number to both sides, because in equations we do have the freedom to add the same number to both sides and still keep the equation the same with the same solutions. Now, next, here we kept the perfect square together, and then we made sure that the number 9 gets out of the brackets and simplifies or is added to -27. So the way we did this before was x squared minus 6x plus 9 stayed together. -9 came out, minus 27. Now, The reason why we did this is because we want to, after completing the square, make it into power of 2, which is x minus 3 squared, and then minus 36. And our job was done in here. We completed the square, converted the equation to vertex form. So we have arrived here, okay? Now, how does that look in a quadratic equation? So very similar to what we did in quadratic functions. So we're going to write this now as a power of 2. So we're going to say x minus 3 squared is equal to 27 plus 9, which is 36. So now this is when the process of solving the equation separates in a way from this process of completing the squaring functions, because this is when we start solving the equation. We're going to say that we are trying to solve for x. This is what we're trying to isolate, but x is inside the brackets locked by this power. So we're going to get rid of that power first. And the way we do it is by taking the square root of both sides. And we know that in an equation, when we take square root, we have to take positive and negative of it. And remember that the power of 2 and the square root will simplify. So we have x minus 3. And then the root of 36 is equal to 6, so plus minus 6. Now we can isolate x more easily. And this would be equal to 3 plus minus 6. So once you brought this to the most simplified form, you can start solving the equation. So you're going to say x will be equal to 3 plus 6, or x is equal to 3 minus 6. So x equals 9, or x equals negative 3. And here we go, we got the solutions. So the key steps that I want you to remember, because it's very easy to mix up the methods, or the way we use a method in a quadratic function and the way we use it in a quadratic equation. And that is because once we're introduced to a certain method, we tend to just go over that like intuitively and by instinct, okay? So the key steps here are, here you group the x and x squared term, here you separate them and you take the constant in the other. So this is one difference. And here you add and subtract the same number, whereas here you add the same number to both sides. Okay, so we're going to take a look at another example. And for this, I'm going to make another video where we solve by completing the square when a is different than 1. Thank you for learning with me, and bye for now.